All right, let's go ahead and get started. If you haven't already seen them, the grades for the first test are in Canvas. I will give those back to you, but I still have a couple of people who need to take it. So after everyone's in, then I'll hand them back. If you are at all concerned with where you stand after the first test grade, please let me know. We can meet and talk about things. Not in office hours though, because those, I mean, if we're going to talk about your individual grade, I want to do those things one-on-one, so we can meet in person or over Zoom. But yeah, if you're at all concerned, let's talk, and I'll let you know where I think you stand going forward. Cool. All right, so chapter basically everything we've done so far has been about, you know, how to integrate. What are some different ways to integrate functions? Chapter 7 is largely about the kind of things you can do now that you have all those techniques. So the quintessential thing you've talked about with integration is finding area between curves and the x-axis. We're going to go a little deeper. We're going to find the area between multiple curves. So, but you can do that with basically techniques you're already familiar with. So I want to find the area between, or basically I want to find the area of that, the region contained in red there. So between e to the x, and so between y equals e to the x and y equals x. So any ideas on how we can find the area basically contained inside here? The top function minus the bottom function. Can you be a little more specific on, like, what are we doing with those two functions? Go ahead. So you're integrating, so you're talking about integrating all at once?
I mean, we can separate, but yeah, we can write it one and two.
Okay. So you said one function minus the other, right? Which one should be subtracted from the other? Okay, so what is the bottom function here? Okay, so here's what I think you're saying: e to the x minus x dx, right?
Yeah.
Okay. So going straight to one integral, why are we able to integrate this using one integral? Why don't I have to find the areas separately?
Property of the measurement.
What property is that?
It's commutative, like you can separate them and there's not a issue.
Okay, so is this a thing I can do? The integral of f of x plus g of x dx, is that equal to the integral of f of x plus the integral of g of x dx? Okay. So I was planning on doing this one separated, but if we're going to jump ahead, we can. Another way I want to explain this is through Riemann sums. So I think when you were first kind of shown area under a curve before you actually ever took an integral, you were probably taught to treat these areas as a bunch of rectangles all stitched together, right? Pretend these are actually rectangular. How do I find the areas of any of these rectangles? Length times width, right? So I tried to do this, but I failed. All these lengths are going to be dx or delta x, right? How do I find the height of any of those rectangles? Delta y. So yeah, since I'm using discrete lengths here, delta x and delta y. So my delta x, you know, when I limit that to become very small, that's what I'm calling dx. How do I find that change in y? Go ahead. Right, it simply is the difference between, if this height is f of x and this height is g of x, it simply is the difference between them. So because of that, yes, even though I can think of the area between both these curves like individually, if I want to find the area between them, I can simply integrate e to the x minus x dx. Is this integral complete? It needs bounds. if I'm gonna find an area, then I have to. Basically, we've described the kind of the verticality of this region, so. Basically the heights of all these rectangles, but we haven't described how to find like basically the horizontal portion of this region. So what are our bounds going to be? How do you know there's 0 and 1?
Says bounded by.
Right. So the graph says it's written there, but I think this is the integral we want to find. So any questions on how we set this thing up? Is this an integral we can do? What is it? What is the integral of e to the x minus x?
This EDX minus X squared.
E to the x minus x squared over 2. All right, let's keep going.
Yeah. Minus 1/2. Minus.
Okay. So finally, e minus 3 over 2. How are we doing? Okay. Any questions so far? Okay, so yes, you can integrate all at once most of the time. So I'll go ahead and skip by this. Like I said, I was planning to do the first one with 2 separate integrals, but we don't really need to. So I want to find the area enclosed between these 2 things. So no graph this time. So I want to find the area between those 2 curves. So taking away some of the information I gave last time. How should we get started here? Go ahead. Okay. Would like to see a graph. Do you have any idea what these things look like? I have a good idea what one of them looks like. And a vague idea what the other one looks like. So y equals x squared. Parabola with the vertex at the origin. Any idea what 2x minus x squared looks like? We should do, sorry, I heard the first part. Something been shifted. Shifted. I think there's another big difference is going to have as well. It's going to be opening downward. So I know it's going to be a parabola. I know it's going to open downward. I don't know if I know exactly where it's going to be oriented. So for now, I have no idea how accurate that is, but that should hopefully help us like organize kind of what we're doing here. So basically I want to find the region that's kind of trapped in between those 2 fractals. So I have a not great looking graph. Go ahead.
Are you going to be dropping on the next test?
No, I mean, you don't need to. I mean, I've not seen that test. So, I mean, the graphing is not part of the objective here. So this was Saul's suggestion. Why did you suggest a graph?
So we can find the bounds.
Okay, so you can find the bounds. I don't know if that graph is going to help us get the exact bounds, but is there something else I can do to get the bounds? Go ahead.
Can you set them equal to each other?
Right, if we set those, so I have y equals 2 different expressions. If I set them equal to each other, I should get their intersection points, which will probably help me clean that graph up a little bit. I know what y equals x squared looks like. All right, so if I solve this thing, what happens? 2x squared minus 2x equals 0. Let's dust off the algebra. Where do I go from there? Factor out the x, and I get 2x minus 2. Now what? Yeah, let's factor out the 2. So I've got 2x times x minus 1 equals 0. So what?
2x equals 0, x minus 1.
Right, so now if I have two factors whose product equals 0, that can only happen if the factors equal 0. If one of the factors equals 0. So I get x equals 0 or x equals 1, right? So I don't like this at all. I mean, I sort of like it. But I think we can now improve upon it. So x equals 1, x equals 0. So I know the bounds now. There's something else I learned that we're going to need to set up this integral, which is what?
Which equation is entire?
Right, so we're going to subtract those functions, right? So the order does matter. Subtraction doesn't commute. So which one of those functions should appear first in my integral? Right, so I mean we have to realize which function, which curve represents which function, but this one should be 2x minus x squared minus x squared dx, bounds from 0 to 1. So I believe that setup is complete and accurate. We have questions about that. Go ahead.
Say it's a more complicated equation and we're not able to really visualize the graph.
Uh-huh.
Is there a way to numerically like pinpoint which one is the
If it's an equation you can solve algebraically, you can do that.
plug in a value and
Yeah, I mean,
bounds?
if you plug in values, so here's the thing, like let's say you have, can I cook up an example here? I'll say this, if you plug in like a point, it'll tell you which one's above the other one, right? But it won't tell you like where that behavior changes.
Right.
So you have to know some interval that we care about here. So like for example, I didn't ask for it, but I could find the area between like -5 and -2. It would be a different integral, a much different problem, but yeah, hold that question while we look at some more wrinkles on this. But so this one I'm asking for the region enclosed by two curves. That means it needs to be two curves where you can find an intersection points. So it either needs to be something you can solve algebraically, or you're gonna need to graph them on Desmos or a calculator or something and find those points. Anything else? We're ready to integrate. All right. So what do we know? What do we do now?
You can simplify it and. It's like 2x minus 2x.
Yeah, I recommend that. Okay. I don't think we can simplify any further. So what's the integral? 2x squared over 2 minus 2x cubed over 3, evaluated from 0 to 1, x squared. So I should get 1 minus 2/3 minus 0 minus 0, right? All told, area is 1/3. Questions? All right, moving on. How about between these two? So probably a definition you're not used to seeing, the area between y squared equals 3 minus x and y equals x minus 1. You can make it equal y. I assume you mean the y squared one, right? So if I have y squared equals 3 minus x, then what does y equal? Is this true? I see some head shakes. Yeah, so I mean. Y squared equals 3 minus X is a parabola, but it opens. Right, I believe. It opens horizontally. In other words, is Y squared equals 3 minus X, is that a function of X? No, I mean, if it looks something like that, then basically we're looking at something that's not a function of X. So that's something we have to be careful of. So basically let's do another graph here to kind of organize what we're doing. So Y equals X minus 1, we understand pretty well. You can do more 45 degrees than that. There we go. And what does my parabola look like? Something like this. So basically, I'm finding this area in here. So if this is what my region looks like, then how am I going to find that area using integration? I have a couple different options here. Go ahead.
You can integrate it in terms of y and use the right line minus the left line.
Okay, so pretty much every integral we've done has been integrating in terms of X. It's not the same, we can't integrate in terms of Y. So, I mean, this is also an acceptable way to find area between curves is the integral from, you know, Y1 to Y2 of f of y minus g of y dy. And you said subtract the right. So basically, what I'm calling f here, you're calling the right hand curve. Why is that?
In terms of y, it's like the greater curve.
But y is vertical, right?
So
Greater would be upper.
yeah. So that's like it.
So it's kind of, yeah, it's kind of a tricky thing, but let's go back and think about this past one in a way we didn't really think of. When we integrated this, we really did the integral from x1 to x2 of y1 minus y2, right? We call them f and g, but really those are y values, right? Where do greater y values appear on the graph? So the y direction's vertical, right? So the greater function, if you're looking at y values, are upper, lesser functions are below, right? So basically the thing we're setting up here is, I'll write this in a different way. The integral from y1 to y2 of x1 minus x2. So basically we're integrating x values. We write them in terms of y, but we're integrating functions that give us x. So that's, hopefully that's a little more friendly as to why we're gonna set the right function as the greater function and the left function as the lesser function. Good. If the right function is the if the right function is the greater function, then let's finish setting up this integral. Or not finish, but go a little further. What should the integrand be? What is the right function going to be in terms of so the right function is the line, right?
Mhm.
But if we're going to integrate with respect to y, that means we gotta x, we have to isolate the x and put it in terms of y. So this integral is integrand is going to be y plus 1 minus something else. So y squared equals 3 minus x is what if we solve for x?
3 minus y squared equals x.
Okay. X equals 3 minus y squared. All right, we need bounds. So how are we going to get those? We have to set them equal to each other.
I don't really understand why the right function.
So it's all about, so the bottom line is no matter what variable we're integrating on is you want to subtract space, you want to have the greater function subtracted by the lesser function. So if we go back to the probably more familiar setting, if we're integrating, basically, we're integrating two functions, right? Or the difference between two functions, f of g, or f of x minus g of x. F of x and g of x are really y values, right? Those are functions that tell you how y is defined. So the way I know what y values are greater is graphically the curve that shows up above.
Yeah.
So y values are, that's the verticality. So the function that's above the other is the greater function. The function that's on bottom is the lesser.
Yeah.
But when we're looking at, you got it right.
It's like a function of X.
Mhm.
Okay.
Not a function of x, but a function that describes x
Yeah.
expressed in y.
Like values would be.
Right.
Okay.
Yeah. So it's all about the, like, kind of, it all kind of goes back to the way that Rene Descartes defined the graphs. Right is positive, up is positive. Good.
So that x equals 3 minus y squared,
Mhm.
is that an inverted parabola instead of what you have listed there? Cause I graphed it and
Does it open left?
yeah,
Okay.
I think that would change our,
That would change. Yeah. So let's get a better graph. I'm confident about the straight line. But now we have a parabola that opens left, right? So because of that, then yes, we're going to change what our upper and lower functions are. Minus y plus 1. Okay. All right, so what's left to do before we integrate? We got to find the bounds, right? So we can do that by setting our, basically we have two functions that describe x, y plus 1, and 3 minus y squared. We can set them equal to each other. Y squared plus y minus 2 equals 0. Now what? Trying to figure out if y'all are factor friendly, or if you like quadratic formula. You waiting for me to do it? I'm not going to do it.
Y plus 2 times y minus 1.
Y plus 2, y minus 1. So y equals -2, +1. Let's say that we didn't fix our graph and we integrated it the way we had before. Actually, I'll hold that question until we finish the right one. Are there any questions about how we wound up here? All right, now what? You want to integrate already? Yeah, let's go ahead and integrate. So area is equal to what?
Oh, wait.
That was the integral of 3. 3y, and then minus y cubed over 3. Yeah. We did not simplify beforehand. We could have. What's it?
yeah.
Minus y. Oh yeah. Thank you. All right, so yeah, let's go ahead and collect some terms. 2y minus y cubed over 3 minus y squared over 2 from -2 to 1. So I get 2 minus 1/3 minus 1/2 minus -4. Plus 8/3. -2. Somebody find my sign flips. I'm worried about at least one place. Or are we okay with it? Okay, so can we get a final number out of this?
Right.
9/2. All right, so a couple of questions. We originally had this integral set up as y plus 1 minus the quantity 3 minus y squared. What would that integral come out to if we had continued that way? It would, if we did everything right, it should be the opposite of that. Which two things, it should tell you right away that, I mean, if as long as your work was free of errors, that means the setup was flawed. We didn't define the greater and lesser functions correctly. Also, if you did everything right, the area is simply the absolute value of what you found.
It doesn't matter. Well.
If so, I mean, I haven't posted yet, but the written homework at least, and I'm guessing the test as well, will ask for the correct setup of the integral. So yeah, even though the fact that basically you're multiplying your integral by -1.
If it's negative, we can just.
What's that?
If we get a negative.
The area, yeah, right. But concentrate on setting up the integral correctly. That is part of this. Another question I wanted to ask: could we have defined this area using functions in X?
Yeah.
How would that have worked?
You would have just had to use 3 equations,
3 equations.
like the 2 square roots. And then the
Right. So if you use the X equations, basically, there's a breakdown kind of at this borderline right here. Oh, didn't want to go that far. But basically, when we were solving this for X, the parabola, we ended up getting 2 equations, one for the positive part of that square root function, one for the negative part. As soon as you go into the y values where you're basically using different functions to define your boundaries, you're going to have to use a separate integral. But yeah, if we redefine this one in terms of y, we can just get away with 1. Any more questions? Go ahead.
How do we get plus 8/3?
How do we get plus 8/3? -2 cubed is -8, right? And there's a, yeah, no, you're good. That was the one I was worried about. Anything else? All right, y'all tell me, how do you want to get started? What do we know? What would we like? What would we like to know? What do we want to see? You want to try this without a graph, or do you want to see one?
I mean, the graphic function is from.
I don't know. It could try it again. A little bigger.
Like there's like the boundaries and then it's all.
Yeah. So it has like those. Yeah. So we know the tangent function is periodic, and it does. Come on, straight lines. So those asymptotes that happen on the tangent function, how often do they show up? Or where do they show up, I guess? pi over two, right? So if tangent is sine over cosine, got to think about where cosine is equal to 0. That's at pi over 2. So let's put this far enough out. Pi over 2. I also care about pi over 4, right? So I know the tangent function. Sort of looks like this. Yeah, let's try again. So that's one period of it, right? So I want to find the area between that and what else? Y equals -1. So horizontal line. Why don't I draw that where it's not going to bother my other labels? Okay, so I think this is getting closer to what we want to look at. Does that help us define the integral? All right, let's start doing it. What am I integrating? Tangent of x. How did you get that?
I tried to look for a top curve over a bottom curve.
Okay. Top curve is tangent x, and what's the bottom curve?
Negative.
-1. So maybe I'll leave this like this for now. Okay, so I believe that is the function to integrate. That's the integrand. Do we know the bounds? What are the bounds? Top bound is pi over 4.
And then inverse negative.
And then I want to know where.
Yeah.
I want to know where those two meet, right? So that's going to be tangent of x equals -1, which means x equals the inverse tangent of -1, which is what?
Negative pi.
Should be negative pi over 4.
You put 7 pi force there or no? Does it matter?
It does matter. So they are different angles, even though they like, if you were to like plot them, they would point in the same direction, but they are different angles. Like for example, if let's say I changed x equals pi over 4 to x equals 400 pi plus pi over 4. That's a coterminal angle, right? But that is a much bigger change in x values. Another way to answer that is if you take the tangent of 7 pi over 4, that's going to be -1. I agree with that. But the inverse tangent function has a very limited range. It will only give you angles back that are between negative pi over 2 and pi over 2. I guess I'll answer this the third way. Based on our region here, based on the way our region is described, I don't think 7 pi over 4 could be another bound of this. So if we did not put it in our graph, but basically we have another line to graph, and that's this vertical one at x equals pi over 4. So now I have this fully enclosed region. Any more questions on how we define the integral? Can we take the integral? What is the integral of tangent x? Do we remember that one? Not secant squared, that's the derivative of tangent x. I'll give you a bit of a hint here. Tangent x is equal to sine x over cosine x, right? How'd you get natural log cosine x?
Use of it.
Yeah, you can do u sub. Basically, yeah, we can set up u sub which would be a little bit longer than what I'm about to suggest, which is something that I think I've brought it before, but you've probably also noticed it. If you have a function in the denominator and the derivative of that function in the numerator, those kinds of things yield natural log integrals. It's not exactly natural log of cosine x. It's negative because I don't have the derivative in the numerator exactly. I have the exact opposite of it. So because of that, this comes out to be negative natural log absolute value of cosine x, which I think for our bounds, the absolute value is not going to matter. So negative natural log of cosine, absolute value cosine x plus x from pi over 4 to negative pi over 4. All right, so how do we start evaluating? What is the cosine of pi over 4? Root 2 over 2 plus pi over 4 minus, what's the cosine of negative pi over 4? Same thing, right? Don't need the absolute values. Minus pi over 4. I believe that's just pi over 2, right? Questions? Happy with this so far? Okay, so let's talk about conceptually what might be going on here. So I have two graphs here, one blue, one red, and y-axis, or basically the y values represent the velocity of these two cars, and the horizontal axis represents the time they've been traveling. If I want to find the area between these two curves, what is that giving me? The amount of distance traveled by who? So I'll call car A, car B. The difference between the distance traveled? How far apart they are? I think is that kind of, are you kind of saying the same thing different ways? Are you sure? Are we sure it's a distance? So this I said was meters per second, so this is a velocity. When you integrate velocity with respect to time, what do you get? You get a displacement, right? I heard acceleration, that's when you take the derivative of velocity. So yeah, derivatives are rates of change. So acceleration is the rate of change of velocity with respect to time. So first, so let's go back to the idea of distance. Are we okay with this integral representing some kind of distance? I mean, it'll be a displacement, but if they're traveling the same direction, that displacement is going to be equal to the distance between them. So in this situation, displacement and distance we can treat as being identical. What if I were to just find the area underneath this red curve? That'd be the distance traveled by A under what basically over whatever time interval, right? So we agree that the area between them is basically, let's say let me give a right hand end to this. If I integrate over the first 9 seconds, then according to you all, the area gives me the distance that separates them after 9 seconds. We good with that? In what unit? In meters, right? Any questions there? Okay. do another trig one. I want to find the area bounded by this region. So I'm giving you the bounds. What else do we need to figure out? Which is the upper function? Can we find out which one is the upper function? How do we do that?
Plug in either four.
Plug in pi over 4, right? So what is the sine of 2 pi over 4? That's equal to, now you tell me. You already told me the cosine of pi over 4 was radical 2 over 2. What's the cosine of pi over 2? Or sine of pi over 2? Should be 1, right? So our upper function should be sine of 2x, right?
Why are we doing that?
Why did you choose pi over 4?
Because it's a value in between 0 and pi over 2.
Okay, so you chose something, could have chosen anything in between those two, right?
Oh,
Could I have chosen 0 or pi over 2?
No.
Let's try it. What's the sine of 0?
yeah.
What's the cosine of 0? Okay. Does that bother anyone? So what problem might we have run into? Well, so I picked two values on this interval, right? And one of them gave me the sine was greater, the other one gave me cosine's greater. So I think most of us made an assumption that probably wasn't safe. What was that assumption? Or what have we now learned? So
But they kind of like cross, right?
they cross in the middle of the region somewhere, right? Because I believe here's what I think we found is that from 0 to something, we're going to integrate cosine x minus sine 2x. Because for some part of this interval, cosine is greater, right? But for the other part of it, sine is greater. Or maybe there's more divisions. We got to find that out. How are we going to find those places where they change position? Set them equal to each other. Sine of 2x equals cosine x. How do we solve that? They have different angles. Go ahead.
Why do you use like pi over 4 of their sine to like pi over 4 when not pi over 2?
Oh, so someone chose a point inside our interval. That could have been anything. I chose 0 to point out like why this is going to be more complicated than it might look. Double angle identity you might not remember is that sine of 2x equals 2 sine of x. Cosine of x equals cosine of x. Now what? How do we finish solving this?
We could plug in that 2 sine of x cosine x from the cosine x.
That's not going to help us find where they cross. So let's do this. I'm going to subtract over the cosine, see if this factors into something a little more friendly. If I factor out a cosine x, I get 2 sine x minus 1 equals 0. So I get cosine x equals 0 and sine of x equals 1/2. No one suggested it, but I'll bring it up anyway. At this step here, is it okay for me to divide by cosine?
Oh, no.
Why not?
Can't divide the function by.
In general, you can, but if I divide by cosine, it's possible for cosine to be 0, right?
Yeah.
So because of that, I can't really, dividing by it might lose things, might cause some errors. But factoring is fine. Where does cosine of x equal 0? Pi over 2, right? Where does sine of x equals a half? I don't think it's pi over 4. That's one of a radical too.
Pi over 6.
Pi over 6. So they're going to cross at the far right end of the boundary. I don't think that bothers me because I'm done integrating there. But they're also going to cross at pi over 6, right? So I think we found the upper bound of this integral. I want to integrate from 0 to pi over 6 to find this. What's the other integral I need to find?
Pi over 6. 0.
To 0?
I mean, to
Pi over 6 to pi over 2 of?
I know. Minus.
Right. So let me stop there. Make sure we're on board with the facts or with why this needs to be 2 integrals.
I have a question, but go back over here. Just a double angle. Like theory, that's the same to sine 2x equals cosine x?
Mhm.
Okay. I just wanted to show.
Yeah, I mean, so
Those are equal to each other?
yes, solving this is really hard without doing that. So I wanted to basically, I gave us a little bit of a shortcut. But basically what we have here is and then sine travels even faster. So to find the area, basically what's going to happen if you treat this all as one integral is you're going to start, calculating this area, but then once you start calculating here, it's going to basically negate some of the area you already found. So if there are no questions about how we got these 2 integrals, can we evaluate? What's the integral of cosine x? Sine x, right? So what is the integral of sine 2x? One half cosine 2x. Positive or negative?
Positive.
Should be positive. So I want to integrate that or evaluate that at pi over 6 and 0, which means I'm going to evaluate the other one. Negative 1/2. Basically, is going to be exactly the opposite, right? What is the sine of pi over 6? Said that was a half, right?
Yeah.
What's the cosine of pi over 3? Also a half. Minus sine of 0, which is 0. Cosine of 0, which is 1. So the first part of this integral comes out to be 2? No. Yeah, so 1/2 plus 1/2 plus 1/4, I think is 5/4. No?
Well, I think it's 1/2 and 1/2. And that's isn't it 0 plus 1/2?
Sine of pi over 6 is a half, though.
Yeah, but when you subtract the 1/2 from the 0 plus 1/2. You go minus,
Right, but that's going to add it.
but shouldn't it be 0 plus 1?
Oh, thank you. Okay. So it's just 1/4. Good catch. So that's part of the integral. The rest of it is, all right, 1/2 cosine of pi, which is -1. minus sine of pi over 2, which is 1. Cosine of pi over 3 is 1/2. And sine of pi over 6 is 1/2. All right, somebody catch my sign flips this time. 1/2 minus 1. Plus 1/2. Did that come out to 1/4 again? Okay, so then what's the final area? Yeah, 1/2, sorry. This area comes out to be 1/4 plus 1/4, which is equal to 1/2. Okay. I got 9:56. Sorry, gotta let you go. If you have questions, please come talk to me. Otherwise, I'll be in office hours in just a little bit, or I'll see you Friday.